So in the previous class we have studied regarding position, change of position, that is displacement, and velocity, speed, and the corresponding xt graphs, position and time graphs. Now in this class we are going to study what is the variation of velocity. In order to describe the variation of velocity with respect to distance or the time, we are going to use a new concept, and that is acceleration. Now Galileo tries to find out whether the velocity is changing with respect to distance or time. Initially it was thought that velocity is changing with respect to distance and time, and later onwards, after keen observation of freely falling objects and motion of the object in an inclined plane, Galileo concludes that change of velocity with respect to time is a constant quantity, and that change of velocity with respect to time he called it as acceleration. Therefore, acceleration is rate of change of velocity. We can define like that. First, we have to study average acceleration. Now, this can be defined in the same manner as that of average velocity. Okay, average velocity ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ, average acceleration ಅನ್ನು ನಾವು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Acceleration ಗೆ ಕನ್ನಡದಲ್ಲಿ ನಾವು ವೇಗೋತ್ಕರ್ಷ ಅಂತಂದೇಳಿ ನಾವು ಕರಿತೀವಿ, ವೇಗೋತ್ಕರ್ಷ. ಓಕೆ, therefore average acceleration, it is the change in velocity divided by time interval in which the velocity is changing. So that is, the average acceleration over a given time interval is defined as change of velocity divided by the time interval in which the velocity is changing. Now we will write the mathematical expression for average acceleration. Let us consider t1 is the time interval. It is the time at which velocity of the particle is v1. Let us take it as the initial velocity. And after some time, that is t2 seconds, the velocity of the particle becomes t2. v2, velocity of the particle becomes v2. v1 is the initial velocity and v2 is the final velocity. Then the change in velocity is v2 minus v1. The time interval is t2 minus t1. Therefore, average acceleration bar A is given by, if v1 and v2 are the initial velocities and final velocities or instantaneous velocities at two time intervals t1 and t2, then the average acceleration bar A is given by v2 minus v1 divided by t2 minus t1. Now v2 minus v1, it is change in velocity, therefore we represent it by delta v, and change in time we represent it by delta t. Therefore, bar A, average acceleration, is given by delta v divided by delta t, change in velocity with respect to the time interval. Now from this expression we can write the SI unit of acceleration. Now what is the SI unit? In the numerator we are having velocity, therefore meter per second, its unit is meter per second, that we have already studied. In the denominator we have time, that is t, that is seconds. Therefore in the numerator meter per second, in the denominator second. Therefore the SI unit of average acceleration is meter per second square. Okay, now this is acceleration, ವೇಗೋತ್ಕರ್ಷ ಅಂತ ಕರಿತೀವಿ. Now we will work out how can you calculate the acceleration. For that one we are going to have a VT graph. Now in the previous classes we have studied xt graph, that is position and time graph. So here we are studying VT graph. What is VT graph? Velocity is taken along the y-axis and time is taken along the x-axis. Previous case alli y-axis alli position vector ತಗೊಂಡಿದ್ವಿ, ಈ ಕೇಸಲ್ಲಿ y-axis ಅಲ್ಲಿ velocity ಅನ್ನು ನಾವು ತಗೊಂಡ್ರೆ x-axis ಅಲ್ಲಿ ಟೈಮೇ ಇರ್ತಾನೆ. ಆ ರೀತಿ ಗ್ರಾಫ್ ಅನ್ನು ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ that graph we call it as velocity time graph or VT graph ಅಂತಂದೇಳಿ ನಾವು ಕರಿತೀವಿ. A graph plotted by taking velocity along the y-axis and time along the x-axis is called a Vt graph. Let me look at one example. Now here we are taking the time along the x-axis and velocity along the y-axis. Now time is measured in seconds and velocity in meter per second. Now the intersection of these two axes is the origin O. Now let me choose an object moving with constant acceleration. In that case, the graph becomes a straight line as shown in that diagram with a blue line. So blue line ನಮಗೆ velocity acceleration ಅನ್ನು curve ಅನ್ನು VT graph ನ curve ಅನ್ನು ಅದು ನಮಗೆ represent ಮಾಡ್ತದೆ. If we take the slope of this blue line, that is VT graph, that slope means it is the tangent, that is opposite side divided by the adjacent side. Therefore slope gives acceleration here. Slope ನಮಗೆ acceleration ಅನ್ನು ಕೊಡ್ತದೆ. Now we will study some other VT graphs for different cases. Now we will study one example how we are going to work out average acceleration with the help of a VT graph. Now we will consider an object which is moving with variable velocities. So initially the velocity is increasing. After a certain time the velocity becomes constant, and in the third interval the velocity goes on decreasing. Now for that one we will draw a VT graph. Velocity is taken along the y-axis and time is taken along the x-axis. Now we will have a time along the x-axis and velocity along the y-axis. With the origin we are having 2 meter, 2 seconds, 4 seconds, 6 seconds, 10, 8, 10, 12, 14, 16, 18, 20 seconds along the x-axis. Now along the y-axis we are having 5 meter difference of intervals, 5, 10, 15, 20, 25, 30 meter per second. It is velocity 30 meter per second. Now we will consider an object is moving with variable velocity. Initially the object is at the origin. At the origin the velocity is 0. Now it starts moving as and when the time increases, the velocity goes on increases. Now up to the 10th second, the velocity goes on increasing. Now after the 10th second, the velocity becomes constant. Now from the first interval from 0 to 10 seconds, the velocity is increasing is shown by a blue line curve that shows the velocity is increasing. Exactly at the 10th second, the velocity remains constant. Now the object is moving with a constant velocity in the second time interval from 10 seconds to the 18th second. Since the velocity is constant, we should get a straight line which is parallel to the time axis as shown in that graph. Now that the straight line, it indicates that velocity is constant. Now as and when the car approaches the 18th second, the velocity remains constant. Then in the third time interval, 18 to the 20th second, the velocity goes on decreasing. That means the car is having a negative acceleration. Therefore we have a decreasing straight line curve. Now this simple graph describes the variation of velocity with respect to the time. Now we are dividing this time interval into 3 intervals. First one is from 0 to 10 second, in which the velocity is gradually increasing. The second time interval, it is 10 to the 18th second. In that the velocity remains constant, and in the third time interval the velocity goes on decreasing. Now we have to calculate the average acceleration in the 3 time intervals. Let me take the first time interval. In the first time interval, at t1 is equal to 0 second, velocity v1 is also 0. After at the 10th second, that is t2 is equal to 10 second, what will be the velocity? In order to find the velocity at the 10th second, now we will draw a vertical line dotted line as shown in the graph. Now it is going to touch the curve, and at that point we are going to draw a horizontal dotted lines. Now that horizontal dotted line represents the velocity at the 10th second. Now it is found to be around 24 meter per second. Now from this simple graph we have V1 is equal to 0, T1 is equal to 0 and V2 is equal to 24 meter per second and T2 is 10 second. Now in this first time interval we can work out what is the average acceleration. So similarly at the 18th second also we are having the velocity remains the constant as shown by the dotted lines. Now we will work out the acceleration. Average acceleration in the first time interval from 0 to 10 second is given by V2 minus V1 divided by T2 minus T1. Now V2 is 24 minus V1 is 0 divided by T2 is 10 second minus 0. So therefore 24 by 10 it is 2.4 meter per second square. So because here we are calculating average acceleration. Now in the first time interval the average acceleration is positive, that is 2.4 meter per second square. Now in the second time interval T1 becomes 10 seconds. Now initial time is 10 seconds and the velocity is 24 meter per second. Now the object is moving with a constant velocity up to the 18th second. Therefore T2 is equal to 18 seconds and velocity of V2 is once again 24 meter per second. Therefore average velocity in this time interval from 10 second to the 18 second is given by 24 minus 24 because the initial velocity and final velocity remains the constant divided by 18 minus 10. It is found to be average acceleration is 0. Average acceleration is 0 in the second time interval. Now let me take the last time interval from 18th second to the 20th second. Now here T1 is equal to 18 and T2 is equal to 20. And V1 is here, it is 24 meter per second. And what about V2? Final velocity, it becomes 0. Therefore, in the third time interval, if you work out the acceleration, it is V2 minus V1 divided by T2 minus T1. V2 is 0 here, 0 minus 24 divided by 20 minus 18. So minus 24 divided by 2, that is minus 12. Look here, we are getting negative sign. What does this negative sign indicates? The acceleration is decreasing. That means it is having a negative acceleration. Negative acceleration. Now this is how we are going to work out average acceleration for different time intervals with the help of this diagram. So next we will study an instantaneous acceleration. Now this instantaneous acceleration can be defined in the same manner in which the instantaneous velocity is defined. Now average acceleration, it gives what is the average acceleration in a given time interval. Previous example ಅಲ್ಲಿ 0 second ಇಂದ 10 second ಗೆ acceleration ಎಷ್ಟು, average acceleration ಎಷ್ಟು ಅಂತ ಕೊಡ್ತಾಯಿತು. ಆದರೆ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಎಷ್ಟು, ಸೆಕೆಂಡ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಎಷ್ಟು, ಥರ್ಡ್ ಸೆಕೆಂಡ್, ಫೋರ್ತ್ ಸೆಕೆಂಡ್, ಫಿಫ್ತ್ ಸೆಕೆಂಡ್, ಹೀಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಆಕ್ಸಲರೇಷನ್ ಎಷ್ಟು ಅಂತ ಹೇಳಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಿಲ್ಲ. ದಟ್ ಈಸ್ ನಾಟ್ ಗಿವನ್ ಬೈ ಆವರೇಜ್ ಆಕ್ಸಲರೇಷನ್. ನಾವು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅಥವಾ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಆಕ್ಸಲರೇಷನ್ ಎಷ್ಟು ಅಂತ ಹೇಳೋದೆ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಕ್ಸಲರೇಷನ್. Therefore instantaneous acceleration at any instant is the limiting value of average acceleration as the time interval is infinitesimally small. That is the definition. Therefore instantaneous acceleration is defined as the limit of the average acceleration as the time interval delta t is infinitesimally small. Infinitesimally small anta helidre here the delta t time interval tends to 0. So instantaneous acceleration is given by the formula limiting value as delta t tends to 0 of delta v by delta t. Now limiting value, as we have studied, it is the calculus notation. Delta v by delta t anta helidre it is the average acceleration. Now in calculus that we are using in mathematics, We can write this instantaneous acceleration as dv by dt. It is the differential coefficient of v with respect to the time t, or derivative of v with respect to the time t ಅಂತಂದು represent ಮಾಡ್ತೀವಿ. The SI unit of instantaneous acceleration is once again the same, that is meter per second square. And the slope of the vt graph, it always gives instantaneous acceleration. Slope of vt graph always gives instantaneous acceleration at that instant. Now we will work out at graph. In the previous class we have studied xt graph, position time graph, and later onwards we have studied vt graph, velocity and time graph. Now we are going to study or draw an at graph. What is that at graph? A graph plotted by taking acceleration along the y-axis and time along the x-axis is called at graph. So in the previous example we have drawn a vt graph as shown in the diagram. For this vt graph we are going to draw an at graph. Okay. ಸೊ ಪ್ರೀವಿಯಸ್ಸಲ್ಲಿ ಒಂದು ಆಬ್ಜೆಕ್ಟು ವೇರಿಯಬಲ್ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ ಅದಕ್ಕೆ ವಿ ಟಿ ಗ್ರಾಫನ್ನು ಡ್ರಾ ಮಾಡಿದ್ವಿ, ಅಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದೆ. ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಗಿ ಎ ಟಿ ಗ್ರಾಫ್ ಎಷ್ಟು ಬರ್ತದೆ ಅಂತ ನೋಡ್ಬೋದು. ಸೊ ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಈ ವಿ ಟಿ ಗ್ರಾಫಲ್ಲಿ 3 ಟೈಮ್ ಇಂಟರ್ವಲ್ ಇದೆ. ದಟ್ ಈಸ್ 0 to 10 ಸೆಕೆಂಡ್. ಆ 0 to 10 ಸೆಕೆಂಡ್ಸಲ್ಲಿ ಆಕ್ಸಲರೇಷನ್ ನಮಗೆ ಗೊತ್ತಿದೆ, ಇಟ್ ಈಸ್ 2.4 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಅಂತಂದೇಳಿ. ಸೆಕೆಂಡ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ಲು 10 to 18 ಸೆಕೆಂಡ್ಸು, ಅಲ್ಲಿ ಆವರೇಜ್ ಆಕ್ಸಲರೇಷನ್ 0 ಅಂತ ಗೊತ್ತಾಗಿದೆ, ವರ್ಕೌಟ್ ಮಾಡಿದ್ದೇವೆ. And in the third time interval from 18th second to the 20th second, we have found that average acceleration is minus 12 meter per second square. With all these data, we are going to draw an at graph. Now consider the x-axis, in which we are taking the time, and y-axis we have taken acceleration. Now along the x-axis time, that is 2 seconds, 4 seconds, 6, 8, 10, 12, 14, 16, 18 and 20, 22 seconds, etc. And in the y-axis we are having acceleration 2.4 meter per second square and 4.8 meter per second square along the positive of the acceleration axis. Now in the third time interval we are having a negative acceleration, therefore we have to take negative axis also. That is minus 2.4, minus 4.8, minus 7.2, minus 9.6 and minus 12 meter per second square in the negative x-axis. Now as compared to the vt graph, from 0 to 10 second, what is the average acceleration? We are having 2.4 meter per second. So therefore, in the at graph, we have to draw a straight line from origin to the 2.4 corresponding to the 10th second. Now that green line, what we are drawing in the green line, it is 2.4, start from 0 at the origin, and it is moving with a constant acceleration, that is 2.4 meter per second square, and reaches the time t is equal to 10 second. Now after 10 second, what happens? We have calculated average acceleration is 0, therefore we have the acceleration 0, that is shown by the vertical green line. Now in the second time interval from 10 second to the 18 second, what about the acceleration? We have calculated it is 0, therefore the green line is exactly coinciding with the time axis. So ನೋಡಿ 10 second ಇಂದ 18 second ವರೆಗೂ green line ಡ್ರಾ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. In the third time interval, that is 18 seconds to the 20th second, acceleration ಏನಾಗಿದೆ? minus 12 ಇದ್ದಾನೆ. What is the meaning of minus 12? It is in the downward direction. Exactly at the 18th second, acceleration becomes minus 12. Therefore, we have to draw a vertical green line here. Vertical green line. Now, and it is constant up to the 20th second. As and when the time appears 20th second, the acceleration suddenly becomes 0. Now that is as shown in that green straight lines. Now this at graph is drawn with respect to the below vt graph of an object. So first time interval alli acceleration is positive 2.4. Second time interval acceleration is 0, therefore the line is coinciding with the time axis. Third time interval we have a negative acceleration, therefore we have a curve in the downward direction. In this manner we can also draw an AT graph. Okay, now we will work out some xt graph for an accelerated motion. So ಈಗ ಇಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋದೇನು ಅಂತ ಹೇಳಿದ್ರೆ an object ವೇರಿಯಬಲ್ ಆಕ್ಸಿಲರೇಷನ್ ಹೊಂದಿದ್ದು, ವೆಲಾಸಿಟಿ ಅಲ್ಲ ಆಕ್ಸಿಲರೇಷನ್ ಹೊಂದಿದ್ರೆ ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಗಿ ಎಕ್ಸ್ ಟಿ ಗ್ರಾಫ್ ಪೊಸಿಷನ್ ಟೈಮ್ ಗ್ರಾಫ್ ಹೇಗೆ ಬರ್ತದೆ ಅಂತಂದೇಳಿ ನಾವು ಡಿಫ್ರೆಂಟ್ ಕೇಸಸನ್ನು ಸ್ಟಡಿ ಮಾಡೋದು. ಸೊ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ನೋಡುವ, ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ನೆಗೆಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್, ಥರ್ಡ್ ಕೇಸಲ್ಲಿ ಝೀರೋ ಆಕ್ಸಿಲರೇಷನ್, 3 ಕೇಸನ್ನು ಸ್ಟಡಿ ಮಾಡುವ. ನಾವು ಎಕ್ಸ್ ಟಿ ಗ್ರಾಫ್ ಅಂದರೆ ಗೊತ್ತುಂಟು, we are taking time along the x-axis and position along the y-axis. Now if the object is moving with the positive acceleration, then we have this beautiful increasing curve. This yellow line indicates object moving with the positive acceleration. Object moving with a positive acceleration. ಒಂದು ವೇಳೆ acceleration ಏನಾದರೂ ನೆಗೆಟಿವ್ ಇದ್ದರೆ, that is decreasing acceleration ಇತ್ತು ಹೇಳಿದ್ರೆ, what will be the xt curve? Don't get confused. ಪ್ರೀವಿಯಸ್ ಅಲ್ಲಿ ನಾವು ವಿ ಟಿ ಕರ್ವನ್ನು ಡ್ರಾ ಮಾಡ್ಕೊಂಡಿದ್ದಾಯಿತು, ಮತ್ತು ಎ ಟಿ ಕರ್ವನ್ನು ಡ್ರಾ ಮಾಡಿದ್ದೇವೆ. ಈಗ ಇಲ್ಲಿ ಬರೀತಾ ಇರೋದು ಎಕ್ಸ್ ಟಿ ಕರ್ವನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಆಕ್ಸಿಲರೇಷನ್. ಓಕೆ, ನಾಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೆಲಾಸಿಟಿ. ಓಕೆ ನಾವು ಸೆಕೆಂಡ್ ಕೇಸ್ ಫಾರ್ ಎ ನೆಗೆಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ಗೆ ಕರ್ವ್ ಹೇಗೆ ಬರ್ತದೆ ಅಂತ ನೋಡುವ. ನಾವು ದಿಸ್ ಈಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಎ ಡಿಕ್ರೀಸಿಂಗ್ ಕರ್ವ್ ಆಸ್ ಶೋನ್ ಇನ್ ದಟ್ ಯೆಲ್ಲೋ ಲೈನ್. ಮುಂದೆ ಹೋಗ್ಬಿಟ್ಟು ಬೆಂಡ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ದಿಸ್ ಈಸ್ ಫಾರ್ ನೆಗೆಟಿವ್ ಆಕ್ಸಲರೇಷನ್. ನಾವು ದ ಥರ್ಡ್ ಕೇಸ್, ಇಫ್ ದ ಆಕ್ಸಲರೇಷನ್ ಇಸ್ ಝೀರೋ, ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತಾನೆ, ಆಕ್ಸಲರೇಷನ್ ಝೀರೋ ಆಗ್ತಾನೆ, ಹಾಗಾದರೆ ಕರ್ವ್ ಏನು ಬರಬೇಕು? ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗೋದ್ರಿಂದ ಎಕ್ಸ್ ಟಿ ಕರ್ವ್ should be a straight line which is making an angle with both the axes. Now therefore this straight line indicates motion of an object with zero acceleration. Zero acceleration ಅಂದರೆ ಏನಾಗಬೇಕು? ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ, ಅದರ ಅರ್ಥ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್. ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಇನ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್. ಸೊ ಹೀಗೆ ಡಿಫ್ರೆಂಟ್ ಕೇಸಸನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. ನಾವು ವಿಲ್ ವರ್ಕೌಟ್ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್. ಸೊ ಈಗ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ದು ಪೊಸಿಷನ್ ಟೈಮ್ ಗ್ರಾಫ್ ವಿತ್ ಅನ್ ಆಕ್ಸಲರೇಟೆಡ್ ಮೋಷನ್. ನೆಕ್ಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ವಿ ಟಿ ಗ್ರಾಫ್, ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಫಾರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಕ್ಸಲರೇಟೆಡ್ ಮೋಷನ್. ಇಲ್ಲಿ ಆಕ್ಸಲರೇಷನ್ ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು ವಿ ಟಿ ಗ್ರಾಫ್ ಅನ್ನು ಸ್ಟಡಿ ಮಾಡುವ. ಕನ್ಫ್ಯೂಷನ್ ಆಗಬಾರ್ದು. ಪ್ರೀವಿಯಸ್ಲಿ ಇಟ್ ಈಸ್ ಎಕ್ಸ್ ಟಿ ಗ್ರಾಫ್, ನೌ ಹಿಯರ್ ವಿ ಆರ್ ಡ್ರಾಯಿಂಗ್ ವಿ ಟಿ ಗ್ರಾಫ್. ನೌ ವಿಲ್ ಲುಕ್ ಅಟ್ ದ ಫಸ್ಟ್ ಕೇಸ್. ವಾಟ್ ಈಸ್ ವಿ ಟಿ ಗ್ರಾಫ್? ವಿ ನೋ time is taken along the x-axis and velocity along the y-axis. Now we will assume that an object is moving in the positive direction with positive acceleration. Object positive direction ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದಕ್ಕೆ ವಿ ಟಿ ಕರ್ವ್ ಏನು ಬರ್ತದೆ ಅಂತ ಹೇಳಿ ನಾವು ಲುಕ್ ಅಟ್ ದ ಡಯಾಗ್ರಾಮ್. ಗ್ರೀನ್ ಲೈನ್ is showing a VT curve. It starts from initial velocity v0 and end at final velocity. ಸೊ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಎಲ್ಲಿಗೆ ತೊಗೊಂಡಿದ್ದೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲೊಂದು ಡಾಟೆಡ್ ಲೈನ್ ತೋರಿಸ್ತಾ ಇದೆ ನೋಡಿ. ದಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಟಿ ಆ ಕರ್ವ್ ಮೀಟ್ ಆಗ್ತಾ ಇರೋದು ಫೈನಲ್ ವೆಲಾಸಿಟಿ. ಹಾಗಾದ್ರೆ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಏನಿರ್ಬೋದು? ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು? ಬೈ ಡ್ರಾಯಿಂಗ್ ಎನ್ ಹಾರಿಜಾಂಟಲ್ ಡಾಟೆಡ್ ಲೈನ್ ಆಸ್ ಶೋನ್ ಇನ್ ದಟ್ ಡಯಾಗ್ರಾಮ್ ದಟ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ವಿ. ನೌ ದಿಸ್ ಗ್ರಾಫ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ motion of an object in the positive direction with positive acceleration. Now we will study the second case. ಒಂದು ಆಬ್ಜೆಕ್ಟು ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದ, ಬಟ್ ವಿತ್ ಎ ನೆಗೆಟಿವ್ ಡೈರೆಕ್ಷನ್. ಅಂದರೆ ಏನಾಗಬೇಕು? ಶುಡ್ ಗೆಟ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಕರ್ವ್, ಬಟ್ ಇಟ್ ಈಸ್ ಡಿಕ್ರೀಸಿಂಗ್ ಇನ್ ನೇಚರ್. Once again, along the x-axis we have time, along the y-axis we are having velocity. Okay. Now we are having a decreasing curve because acceleration is negative. Now initially we have v0 and final velocity find out ಮಾಡಬೇಕಾದ್ರೆ ಟಿ ಇಂದ ಒಂದು ವರ್ಟಿಕಲ್ ಲೈನ್ ಹೇಳ್ಕೊಳ್ಳಿ, ಡ್ಯಾಶ್ಡ್. ಅದು ಎಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಟಚ್ ಆಗ್ತದೋ ದೆನ್ ವಿ ಹ್ಯಾವ್ ಟು ಡ್ರಾ ಎನ್ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ದಟ್ ರಿಪ್ರೆಸೆಂಟ್ಸ್ ದ ಫೈನಲ್ ವೆಲಾಸಿಟಿ. Now this is the curve for an object moving with moving in the positive direction with negative acceleration. Now you study two more curves for the case. Now in this case, an object is negative moving in negative direction with negative acceleration. Direction negative, acceleration negative ಇದ್ರೆ ಕರ್ವ್ ಏನು ಬರ್ಬೋದು ಹೇಳಿ. ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿಗೆ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಫೋರ್ತ್ ಕ್ವಾಡ್ರೆಂಟಿಗೆ ಹೋಗಬೇಕಾಗ್ತದೆ. Along the x-axis we have time, along the y-axis we have the velocity. So since the object is moving in the negative direction, therefore we have taken the starting initial velocity in the negative of y-axis, that is v naught. Now since the acceleration is a constant one, we are getting a straight line. Now this is the decreasing one. Now this represents an object moving with negative acceleration in the negative direction. Okay, object. Now what is the final velocity? So by plotting the dashed lines you can get the final velocity. Now look here, initial velocity is also negative, minus v naught. Final velocity is also negative, it is minus v. Why? Both are in the negative of y direction. Clear? Now this is the motion in negative direction with negative acceleration. And lastly we study motion of an object which is going to change its direction. Now look at the diagram. We have the time axis and we have taken time t1. After time t1, the object is going to change its direction. That case we are going to study. Now initially we have the object v naught velocity. Now from that one it is moving in a positive direction. Object is moving in positive direction. Up to the time t1 it is in the positive direction with decreasing velocity acceleration. At the time t1 it is going to reverse the direction. At time t1 it is going to reverse the direction. So therefore that is time t2 and the corresponding velocity is minus v. Now carefully look here, from 0 to t1 second object is moving in the positive direction with the negative acceleration. At the time t1 the object is going to change its direction. Therefore from t1 second to the t2 second object is moving with negative acceleration in the negative direction. So ಮೇಲ್ಗಡೆ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಇರ್ತಾನೆ, ಸೊ ಕೆಳಗಡೆಗೆ ನೆಗೆಟಿವ್ ಡೈರೆಕ್ಷನ್ ಇರ್ತಾನೆ ಅನ್ನೋದನ್ನು ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕು. ಮೋಷನ್ ಆಫ್ ಎನ್ ಆಬ್ಜೆಕ್ಟ್ ವಿತ್ ನೆಗೆಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್, ಎರಡೂ ಕೇಸಲ್ಲೂ ಆಕ್ಸಿಲರೇಷನ್ ನೆಗೆಟಿವ್. ಸೊ ಮೇಲ್ಗಡೆ ಡೈರೆಕ್ಷನ್ ಪಾಸಿಟಿವ್, ಕೆಳಗಡೆ ಬಂದರೆ ಡೈರೆಕ್ಷನ್ ನೆಗೆಟಿವ್, ರಿವರ್ಸ್ ಮಾಡ್ತಾನೆ ಅಂತ ಹೇಳಿರ್ತಕ್ಕಂಥದ್ದು. Now that is regarding the Vt graph for constant accelerated motion. Now we have one more important concept, that is area under Vt curve. Now what is a Vt curve? A curve plotted by taking velocity along the y-axis and time along the x-axis ಅಂತ ಹೇಳಿದ್ವಿ. Now here look here, we are taking time along the x-axis and velocity along the y-axis. Now we will plot a graph. An object is moving with the constant velocity. ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ವಿ ಟಿ ಗ್ರಾಫ್ ಆಗಿರೋದ್ರಿಂದ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದ್ರೆ ವಾಟ್ ಶುಡ್ ಬಿ ದ ಗ್ರಾಫ್? ಇಟ್ ಶುಡ್ ಬಿ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಪ್ಯಾರಲಲ್ ಟು ದಿ ಟೈಮ್ ಆಕ್ಸಿಸ್ ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ. ಓಕೆ, ಸೊ ವಿ ವಿಲ್ ಪ್ಲಾಟ್ ದಟ್ ಗ್ರಾಫ್ ಅಟ್ ಎ ಟೈಮ್ ಕ್ಯಾಪಿಟಲ್ ಟಿ. ವಾಟ್ ವಿಲ್ ಬಿ ದ ವೆಲಾಸಿಟಿ? ಇಟ್ ಈಸ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್ ವಿ ನಾಟ್ ಅಂತಂದೇಳಿ ನಾವು ತಗೊಂಡ್ರೆ, ನೋ ದಿಸ್ ಈಸ್ ದ ಗ್ರಾಫ್. Now this graph represents an object moving with a constant velocity v naught up to the time capital T. Clear? Now we have got a rectangle here in this graph. Now what is the area of the rectangle? We know that it is length into breadth. Now what is the length here? It is the time capital T. What is the breadth here? It is the velocity v naught. So v naught into t ಅಂತ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ, so it gives area of this rectangular. rectangular slab. Now that area is denoted by the red color. Now that gives the area, and area is given by V naught into T. Okay. Now we work out the area. Area under the VT curve, it represents is equal to displacement that we are going to show. Okay. Now look here. The area under the curve straight line is parallel to the time axis. Therefore, area is equal to V naught into capital T. That is equal to V naught into T. But according to the definition of velocity, velocity is equal to distance divided by the or displacement divided by the time taken. Velocity is displacement divided by the time taken. Therefore, displacement is velocity into time. We know velocity is displacement by time. Therefore, displacement is equal to velocity into time. ಇನ್ನು ಮೇಲಿನ ಕೇಸಲ್ಲಿ V naught ಅಂದರೆ velocity, capital T ಅಂದರೆ time. Therefore, V naught into time, that is area under the VT curve, always represents displacement. Very, very important concept. You should remember this one. Now, this much is enough for today's class. Thank you for watching.